All right, guys, we are going to do practice problem number 1. This is number 1 of the assignment posted on Google Classroom. Step 1 is to read our problem. And so if 98 grams of Fe is produced in the reaction, how many moles of hydrogen are produced at the same time? And you're given a balanced chemical equation. So our first step is always to find our given and our need. Our given is whatever has a number and is units. And so right here, I have 98 grams Fe. And then how I find my need is I look for whatever follows how many. And in this case, we're looking for a certain number of moles of hydrogen. Next step is to draw my train tracks. And I always put my given in the top left corner. First thing I need to do is cancel out grams of Fe to get moles of Fe. And I'm going to use my molar mass to do this. So what that means is I need to look at my element box for Fe. And I have 55.85. So that means I have 55.85 grams of Fe per 1 mole of Fe. I then need to convert, or I've now canceled out grams of Fe, and now need to convert moles of Fe into moles of hydrogen. And I'm going to use my balanced chemical equation for this. So the coefficient in front of Fe is 3. So I have 3 moles of Fe. The coefficient in front of H is 4. So I have 4 moles of H2. All right, our next step is to multiply across. So I have 98 times 1 times 4 divided by 55.85 times 3. You would plug this into your calculator. Top number always goes first, and everything on top needs to be in your parentheses, and everything on the bottom needs to be in parentheses. And when I plug this into the calculator, I get 2.34 moles of H2. And that would be my answer. So now let's go over the structure that you're going to use. Anytime that you are given grams and you need moles. So we're going to draw our train tracks, and we are always going to put our given in the top left. In this case, our given is in grams. So I need to cancel out grams, so I'm going to use my molar mass, which is in grams per 1 mole. Now remember, guys, everything, my molar mass is going to be the molar mass of my given. And this is also moles of my given. Next, I'm going to need to cancel out moles of my given. Sorry, not 1. Just moles of given. To get moles of need. And you're going to get these numbers right here from a balanced chemical equation. So you're going to pull whatever coefficient is connected to your given and your need. Remember, if there's not a number, there's an imaginary 1 in front. But if you plug things in, here you start with your given. You then use your molar mass of given because your molar mass is in grams per 1 mole. We end up with moles of given. You then plug in moles of given and moles of need from your balanced chemical equation. And you're going to multiply across and divide down. Remember to put everything in parentheses.